Hello everyone, today is our first lecture of Verilog HDL. Verilog HDL stands for Verilog Hardware Description Language. Hardware description language are those languages which help us to implement any logic into hardware. By using these languages, we implement any logic or any digital designing part in the hardware. Today is our first lecture on the basic of VIVADOs, Verilog, and we implement the basic combinational circuit code. So here we create a project by just naming this half adder. By selecting this, by default this was selected the RTL project, and just we have create the file. We have named as HA because H stands for half and A stands for adder. By creating this, next by default this setting was defined. And here we are project is initializing. Just click on OK. And in the design source, our source file in this which file we can write our code, we write our the source code was created with extension .v. .v stands for Verilog. By default the module and end module keywords are defined, and this the HA means the file name or the module name. The parenthesis after the half adder after the HA, which was for the parameters or inputs or outputs. We have defined A, B, S, C. Here we define four parameters, four variables or parameters, two for inputs, two for outputs, for which the variable which for input we define by the input keyword A, B, and it is a basically syntax of the C language. So by every expression we need the semicolon at the end. Output S, C. Here our variable was defined, which of them are input, which of them are output. Now we have write the expressions for the sum and carry. S stands for sum, that's why we here write is sum, and C stand for carry, C out. And here also we will have to change the name. Okay, for defining the expression we use the assign keyword, assign, and the variable name S means sum, which is equals to A XOR B. So A and symbol of XOR is this, and B this. And for the carry one we assign C out, equals to A and B. By writing this only this codes of lines of codes, we have designed our half adder circuit. And for looking into the design, we click on the open elaborate design and click on OK. Just reading the netlist which we have defined, and it's loading the overall schematic of our code. Here we have two inputs A and B, which was inputs in the AND gate, and AND gate output is our carry, and the XOR gate output is our sum. So this how the schematic was look like of the half adder. Then if we have to test the code, then we have to write the test bench. For the test bench we click on the add source, add or create the simulation file. Please select this and next. Create file named as half adder underscore TB. TB means test bench. If you want to do any kind of name, then you have to do finish. Okay. In the sources, go on the simulation, sim1, click on the HATB, and here is our test bench was created. In the test bench, the outputs are defined by the wires and the inputs are defined by the register. So we have the register keyword and define the input, and wire keyword for defining the outputs. And here in this code, our output is sum and cout. By doing this, if we have to test the test this file by due to this h_tb, so we have to instantiate the source file in this here in this code, because how test bench knows how test bench knows that how test bench knows that it was checking the source code named as HA. So we just write HA, UUT means unit under test, parenthesis. We have just instantiate like this. In the same manner, how here we define the variable sequences, in the same manner we have right here A comma B comma S UM C out and semicolon. In this way, the module name HA was instantiate under the h_tb. Okay. Now we write the initial command. By initializing, we use begin and end by default. In this, we have test our source code by using their input variables. The source code input variables are A and B. So here we just define A equals to 0, B equals to 0. Okay, means in this test bench the initial was A equals to 0 and B equals to 0. Hashtag 10. Hashtag 10 means after every 10 nanosecond, every 10 nanosecond the inputs just change from 00 to 0 1, and after again 10 seconds our input is changed from 1 0 1 to 1 0. Okay, and after again 10 seconds our input is changed from 1 1 to 1 0 to 1 1. Here we have two variables, that's why we use all the four possible combination, and here we end our test bench by giving this command hashtag 5 dollar sign, where is our dollar sign finish. This command signifies that after 10 10 10 30 or 30 after 35 seconds the waveforms simulation was stopped, and here we use all the possible four combinations. So here we save this. By saving this, you have look into this. HA_tb contain UUT HA, means this test bench test this file name was HA. So by clicking on the run simulation, we run the simulations. Yeah, just look at here. For initializing, the A or B are 0. That's why sum and carry was also 0. And at the 10 second, the A variable was 1. A variable was assigned was 1. B is 1. A is 0 and B is 1. That's why sum is 1, carry is 0. And the next 10 second, at the 10 nanosecond, the inputs are changed from 1 to 0. That's why the sum is also 1 and carry is also 0. At the 20 second, at the end of 20 second, our variable was 1 comma 1, means A is 1, B is 1, and 1 sum is 0 and carry is 1. And at the 35,000 nanosecond, means 1000 nanosecond means 1000 nanosecond means hashtag 1. That's why 35,000 nanosecond our waveform was finished, because we have applied here hashtag 5. If we change this to hashtag 15, then this was finished up to 45. So here we just reload it. You have seen that at the 45 seconds, the waveform simulations was stopped. So this was our half adder. Is a basic combination circuits which was used in the full adder, triple carry adder, and this was just half adder, and this was test bench. This was simulations, and at the last we have looked into it the schematic, and this was the schematic. In the schematic we have changed the background also by using these sections. We have just used the by default background yellow. Yeah, this was the. So thank you everyone for watching this video. Stay tuned.